What's up, 7th graders? Mr. Morris here again. We have about a week left of school, which is hard to believe. It's crazy that it came this quick, and it's still such a weird time, and I'm really disappointed that we aren't able to wrap up the year together. But I wanted to make another quick video related to something that I really hope that you are able to take with you into 8th grade. Something that we didn't quite get to while we were together in school was talking about what are called linear relationships. And it's going to be really important that you understand that idea in 8th grade. And you already know a lot of the basics of what a linear relationship is based on what we did do earlier this year, but I want to make sure that we can really quickly go through some of the foundations, the fundamentals of what you really need to know. And I'm going to walk through 3 really important parts of linear relationships. Whenever you talk about linear relationships, you can think about, oh, I know how to represent that in a table. I can represent a linear relationship in an equation, and I can show that relationship on a graph. All right, so I'm going to walk through those 3 really quick essential parts of what a linear relationship is, what it looks like, and how we can talk about it. I'm going to do that in 3 separate videos so that we can focus on each of those parts separately. And today I'm going to be talking about something that is really relevant right now related to the coronavirus and the COVID closure. We've had to really adjust a lot of the things that we do in our everyday life. And one of the things that I've had to learn how to do, and hopefully you have, is to wear a mask whenever I'm outside, whenever I'm around other people, going to the grocery store. I've always got to have my mask with me. That's not only to keep me safe, but it's also keep everyone else around me safe so I'm not spreading my germs to them. So I hope that you all are getting used to wearing your masks when you're going out so that we can slow that curve so that we can make sure that everyone in our community is staying safe. Everyday people like us, we need to be wearing masks when we're going outside, but also something that, has presented a challenge, an additional problem because of COVID-19 is that hospitals have been worried about their workers running out of masks. So there's concern that people who work in hospitals with the people who are the most sick right now with coronavirus, they're going to run out of masks because they're using them up so often. And so I want to talk through 3 different hospitals and how they are using masks and their concerns needing to figure out how long will their stockpile of masks last for their workers before it's a really big problem. All right, let's take a look at those 3 hospitals, and then we're going to work through linear relationships in a table, equation, graph. Here we go. All right, so first up, we know some information about hospital number 1. Hospital number 1 uses a total of 150 masks per day. Next up, hospital number 2 uses 200 masks per day. And lastly, hospital number 3, they also use 200 masks per day, but they also did something different. They used 200 masks per day, and they donated 50 masks to a grocery store. All right? Looking at these 3 hospitals, we have information about the relationship between the number of masks and the number of days. When I say we're looking at linear relationships, you know that we are looking to explore how are 2 different variables related. So the variables that we are talking about are the relationships between the number of masks and the number of days. That's going to be important as we write equations, make tables, and draw graphs. We're now going to take that information and we're going to record it in our 3 tables. We've got a table for hospital 1, we've got a table for hospital 2, and we've got a 3rd table down here for hospital 3. We're going to take the relationship information between the relationship of number of days and number of masks and record it in this table. I'll start off by using blue for hospital number 1. Well, after 0 days, how many masks would there be? Well, if there's been 0 days, then they haven't used any. So at 0 days, it's 0 masks. They use 150 masks per day. So after day 1, they've used 150. Another day goes by, and now they've used 150 more, which is a total of 150 plus 150 more is. Another day goes by, they use 150 more, so there's a total of 450. Another day goes by, now we're at day 4, they're still using 150 per day, so it was 450, adding another 150 is a total of 600. And after day 5, they've used a total of 750 masks. Day 2, I'll switch over to red. Well, we know that still, after 0 days, they've only used 0 masks. They haven't had the chance to use any yet. All right. Each day they use 200. So after day 1, there's 200 masks are gone. Another 200, another day goes by. So that's a total of 400 masks are used. 3 days is going to be a total of 600 masks. 4 days is a total of 800 masks. And after 5 days, they've used a total of 1,000 masks. All right. Hospital 3, remember, they did something different. Before they started giving any of their masks to their workers, they decided they needed to donate 50 masks to a local grocery store to make sure all those workers at the grocery store were staying safe. So unlike Hospital 1 and 2, where after 0 days they hadn't used any masks, how many masks did Hospital 3 use at 0 days? Before they gave any masks to their workers at 0 days, they already used or donated 50 masks. All right, then 1 day later, they used 200 masks, which means they used a total of 250 masks. Another day goes by, they use another 200 masks, means that's a total of 450 masks. 650, 850, 1,050. Looking at these 3 tables, this information looks pretty similar to what we were talking about in school before the schools were closed. We were talking about rate tables and constant of proportionality. We said constant proportionality is whenever the numbers are increasing by a constant number. Each day here, the number of masks are constantly increasing by 150. Down here, the number of masks are constantly increasing by 200. Down here, what's the constant of proportionality? Each day, there's 200 more masks, so the constant of proportionality is still 200. This is the beginning of a linear relationship. You all know what this looks like. This is the foundation, and we're going to use this to explore a little further.